Welcome to our discussion of nuclear chemistry. In this introductory video, we're going to define what a nuclear reaction is, discuss natural radioactivity and its causes, and identify the particles involved in nuclear reactions. So a nuclear reaction is a change that occurs within or among atomic nuclei and is represented by a nuclear equation like the one below. So we call it a nuclear reaction because it involves just the nucleus of an atom or the nuclei of several atoms. So nuclear reactions are represented by nuclear equations. And remember that when we represent elements in this format, that our atomic mass is on the top and our atomic number is on the bottom. So for this isotope of nitrogen, it has an atomic mass of 15 AMU and an atomic number of 7. And also notice that the elements on the reaction side are different than the elements on the product side. And one final thing to notice is that the sum of the numbers on the left equal the sum of the numbers on the right. So 15 plus 1 equals 16, and 12 plus 4 equals 16. And on the bottom, the same is true. 7 plus 1 equals 8, and 6 plus 2 equals 8. And this demonstrates that electric charges must be conserved in a nuclear reaction. One type of change that an atomic nucleus can undergo is called radioactive decay, in which the nucleus actually disintegrates. When this change occurs naturally or spontaneously, we call it natural radioactivity. As a nucleus disintegrates, subatomic particles or photons are emitted, though sometimes you can have both subatomic particles and photons being emitted during radioactive decay. When radioactive decay causes one element to become a different element due to this emission of subatomic particles, we call it transmutation. So if we take a look up here at our nucleus, we have a carbon-12 nucleus. But let's say that my blue circles are protons and my pink circles are neutrons. Well, since I have emitted one of my protons, this atom is no longer carbon-12, but has instead transmutated into a boron atom because it lost a proton. So what causes radioactivity? Well, radioactivity is related in part to the ratio of neutrons to protons. And in a nucleus, the protons and the neutrons together are actually called nucleons. And if we think about a magnet, if we have two positive ends of a magnet facing towards each other, they're going to repel each other. So the same should happen with our two positively charged protons. Since they have the same charge, they should repel each other and essentially fly out of the nucleus. So really, we should have all of our atomic nuclei sort of falling apart because of the protons repelling each other. But this isn't what happens. And this doesn't happen because of something called the nuclear strong force. And the nuclear strong force is the glue that holds the nucleus together and overcomes the repulsion of our protons. However, if this strong force isn't enough, the element becomes unstable due to an unbalanced ratio between neutrons and protons. So in order to try to correct this imbalance, the atom will go through radioactive decay or natural transmutation, in which radioactive or unstable nuclei break down naturally in order to become more stable. And this may actually take a series of steps or a series of decay reactions to achieve. So it might have to break down in several steps in order to reach that stable ratio of neutrons to protons. Also, the larger an atom's nucleus is, the more likely it is to be unstable. In fact, elements with atomic numbers greater than 83 have no known stable isotopes and are all considered to be radioactive. And that wraps up our video on nuclear chemistry and introduction. Please bring any questions you have with you to class.